This is the second video about 3D printing and blacksmithing. I guess this is more of the finishing part of blacksmithing, the bladesmithing part of it. And this is essentially my knockoff of the Oliver Tobin Universal Blade Jig. So essentially what this is a solution to how unergonomic the 2x72 grinder is. So this right here is the Housemade 2x72 grinder. You can buy these, they send it to you in a few boxes with all the parts that you have to weld together, and then it turns into this grinder. I'll show you the whole thing here. It's a really nice 2x72. You have a variable frequency drive. So for the Housemade grinder, you buy the variable frequency drive and the motor separately, so you can kind of mix and match what you like the most. They even have this 3D printable file to hold the little rheostat for the VFD, which is really nice. This is a nice versatile grinder. You can turn it 90 degrees in that direction, and so you can grind horizontally. And I've been very happy with this, but the inherent issue with all 2x72 grinders, all stand-up grinders with a vertical platen like this, is that they're just not ergonomic for when you're doing a lot of grinding and you're constantly pushing on that platen when you're grinding blades. What it does, I'll show you a blade for reference. So what you do is that you set the distance of this top piece forward or back, and what that does, it changes the angle of the spine in relation to the edge. Reggie. And you can bring it forwards and back, and then this part here is what you use to push. So rather than awkwardly messing up your back by constantly pushing the blade on the platen, I found that this is a very elegant solution. This guy's really smart. He developed a way so that way you can put very little pressure across the blade and essentially grind it to completion. And this is an excellent design. The only problem is that it's almost $500, and I didn't want to spend that, and I wanted a good challenge on what I could make with my 3D printer and my modeling. So what I did was create a sliding piece here, and you'll see one of the funny things about this is that it doesn't seem like it should work, because this can actually be pushed back. The spring is a return spring on the side, these springs. It's a return spring that returns it forwards, but this bolt in the back that you can actually 3D print little wing nut attachments, it keeps it from going any further forward. But you would think, oh, well, you push the blade on it and then it would push this back constantly. But the weird thing is, because the blade is pushing on the little ledge here, this little surface, and it's pushing on here, it kind of cancels out. So no matter how hard you push, it's kind of an equal and opposite force on both this and the platen. So I'm going to set this up here and then start grinding. Bring it back just a little bit. Yeah, that's looking better. Especially for rough grinding, initial rough grinding, establishing that bevel, this is a godsend, because you can just slap a 36 grit belt on there and go to town and get it all the way thin like you need it to, and then work up the grits. Where this doesn't work is that I feel like this design is still for, initial grinding. It's not really meant for finishing. If you try to get a nice flat bevel with a 220 grit, you're still going to end up eating away on those edges of the belt, no matter what you do, no matter how flat you think you have it with the belt. Now, this might be because I just don't have enough time under the on the belt, or under the belt, whatever you want to say, pun intended. And maybe I can eventually master this tool so that I can basically finish it to the very end. In Oliver Tobin's original video, he has this, he basically finishes it to completion, more or less, and I just don't have that kind of skill with this machine yet. So I think I might adjust it in the future, I might modify it a bit, but I think it's finally at the point where this design is very usable and I can use it in my day-to-day knife making. This is Reggie, the shop cat. He is a mouser and just a wonderful little tuxedo cat, and he really wants to scratch me right now. What a sweet cat. Oh my goodness. All he wants is food, and then sleeps, and then he goes out hunting. Okay, yes, that was a warning. I'll go give you some food. This right here is the new version of the Universal grinding jig. So you'll notice it's a lot more bulky, and what makes this one different is that not only does it have the same regular function where you have your arm and then you can put a blade in there and grind it. Oh, I forgot to tighten that. There we go. And then you can grind it like that. Not only can you do that, but if you loosen the back here, and it's locked in there pretty well, you can loosen it like this, pull it back, and now you can rotate it like this. So the way I designed it is that you have 0 degrees, 15 degrees, and then 30 degrees. I don't see any reason to go all the way up to 45, because that, I think, is kind of overkill. It's not very relevant for this type of knife grinder jig. Now, why did I make it so you can tilt side to side? The reason being is that with the previous design, you could just grind and grind in this one position, right? What happens when you switch belts? The scratches are going the exact same way every single time you grind it. So instead, you go from a 36 to an 80, let's say, and you want to make sure that you get all the grind marks out. You pull it back, put it at a 15-degree angle, lock it down, and then you do your passes like this, and then you can have you can see the cross hatches on the blade, and then once you're done with that grit, all those crosses will be gone. It'll just have the same lines all the way down. And I found that this actually works very well, and it's not too big of a hassle. So basically every other belt you're going to be grinding flat, and then on the intermediate belts you're going to be going 15 degrees one way like this, and then 15 degrees the other way, where you switch it around, and then you go like that. And it's actually really not that hard to switch it around, because it just kind of locks in the back here. And I got some really good results. Let me go get the blade that I finished with this process to show you. This is the blade that I finished up to a 400 cork on this grinding jig, and it worked wonderfully. I could get the tip really thin, I got it really thin behind the edge, very consistent, and it was all with this jig. I did not do one bit of freehand grinding with this jig, And because I was able to rotate it side to side like this, because I was able to rotate it like this, I don't want to touch it to that 36, but because I was able to rotate it, 15 degrees back and forth, it allowed me to just go up through the belts and get a really good, consistent result in the end. And I hate grinding, and this makes it so much easier now. So all I have to do basically with this is get the shoulders even, use my small wheel to get it smoother behind the heel, finish up the spine with a higher grit, and then put a handle on it. But for the bevels, this works wonders. This is the old design of the grinder jig, and you can see it's a little bit more bulky. Let me try to put it here. So you see it's a little bit taller. You don't quite have as much belt space above. Not that you would really need that much. Maybe for a ridiculous Chinese cleaver you'd need that much clearance, but less plastic, everything's closer together, everything's a bit more sturdy. I find that trying to miniaturize everything while still keeping it functional works great for 3D printing, because the faster you can print it, the faster you can prototype, and the better your results. So that is the angled tilting Universal Blade Jig, or however you want to call it. Yeah, this was the first iteration, and I could actually bolt this one down to the jig. I put the holes in the wrong spot for this one, so I'm just clamping it on. I'll probably put some holes back here, so that way it can I can mount it to this metal piece. So one of the key features of using this jig is that you want to grind the blade as if you're keeping it at the same height the whole time. So picture this. You have the heel at this height, and because the angle of the bevel is based on the relationship between the spine and where the edge meets the belt, what you want to do is, as you pull it through, try to rotate the blade up and keep it at that height right there. It'll be a little bit different when you're grinding and the blade is constantly pushing down, so that way it keeps it firmly secured to the jig here. And so you're going to be turning it about that much, which is why it's crucial to have a dedicated piece that you actually mount this to, because if you don't, then you're going to end up bumping into your work rest. So you'll have to do a little bit of welding or get creative with how you mount this type of jig. I might even see if I can 3D print one, although that'll take a lot of plastic and a lot of time. So we'll see. This is a piece that I'm not sure if I'll be able to finish. I burnt the edge a little bit right there, but I can use this as an example. On the previous jig, I tried to freehand it at an angle, but with this, now I can actually put it at an angle. So let's see here. The way that you want to set these up is to, first of all, loosen this and have it spaced a little bit farther away. So you want to loosen it until the handle in the back is completely loose, and then you tighten it until you feel a bit of force and you see the jig just barely come back. That way you know that that tension has started. It already has spring tension in it, but that's when this handle engages. And so now what you do is push it up so it touches the belt, tighten it down, and then you want to bring it back so that it's not touching the belt. Eventually you'll come across some knives where you need them really thin, so you'll end up grinding into the actual jig itself, the metal part at least, but these are all sacrificial. They're pretty easy to make. I just chiseled the opposite side of this and then bent it in a vise. And despite doing it all by hand and by eye, I think that it's worked out pretty well as far as squareness. I found that just making a dedicated jig is much easier because you can just remove it. It doesn't move the piece at all unless you got a clamp there. Yeah. So I'm gonna probably start out at 120. First I'll get the belt to track right. Okay. And now I will look down the blade here. Pull it back. I see a gap behind the edge, so it needs to go forwards. About right there. Looks good. Okay. Now, always wear your respirator when using this, when grinding in general. Some of my friends have no respect for the metal dust, and one of my friends, he doesn't quite have silicosis, but it was bad enough that he can't get an MRI because of the metal in his lungs. So always wear your respirator when using this, but just for the purpose of this video, I won't wear one. So I'm going to set it at a 15-degree angle. Pull it back, and even though it pulls back, the gears that are actually on the end here, let me show you. It has these gears that interlock with this, and you have all these bolts that are in there that hold all the pieces on top secured. So I'll put it at, let's see, 15 degrees. Tighten it down, and that should be the exact distance from the belt that we had earlier. All right, and now I'm gonna start grinding. So you'll notice that the belt was rubbing against the platen, but that's just because I put at an angle, and where the belt was clear when it was horizontal, when it's at an angle it started rubbing against it, but that's really not an issue. So here you'll see for the most part the scratches going this way, not vertically but slightly diagonal. I'm starting to see a lot of those, as well as the diagonal scratches that are going this way that I need to get rid of. Now I'm looking through here, I'm seeing exactly where these scratches are. Now right here I see that it's mostly on the edge that I'm getting the fresh grind marks, so I'm gonna adjust the angle a little bit so that way it's a little bit more acute, which means instead of tightening it, you loosen it to make the angle slightly more acute. Of course it's gonna rub more once I turn it on, but all these need to be broken in. All right, so now you might notice from the last time I took it out, there's the grind marks. They used to be about here, but now they're up here. so I'm just getting a little bit closer to where the original angle was. But so far it's looking pretty good. A lot more consistent in this area. I almost burnt the tip here, so I would recommend, if you can find, well, I guess if I find parts that are stainless to include with this, you can actually use a spraying system to use with this, so you can just keep grinding and never dip. In fact, with this Housemade grinder, I actually got a mister that I've never used, so this might be a good time to try to use it. It's essentially an air compressor hose. You put that on there, and then you put a dip tube in a bucket, not your slack bucket, but some fresh water, and then it uses, I think it's the Venturi effect, to spray water onto the belt, and that should keep your blade cool. So if you do a big batch production, I would definitely recommend you use a sprayer with this. But since I'm still in the prototyping phase of this, I'm not really using that. Here's a good example of rough grinding. This blade has not been heat treated yet. Granted, I did grind it a little bit too thin at the edge, but that is the kind of result that you can get from this jig, which I think is pretty good. That's a very consistent grind line all the way down, especially for a forged blade using a jig, because there are not many jigs that can handle all the different tapers of this blade. So I'm very happy with that. These pieces here are meant to adjust the height of the arm, so that way if you're using something that's a lot wider and you don't really like that, you don't have much force on it, you can bring it up and have a bit more force to press it against the belt. But overall, I've actually found that that is not super necessary, because as long as you keep those RPMs high, the name of the game with this type of jig is high belt surface speed and low pressure. So you're really not pressing too hard on this. All right, so I wasn't quite able to get that little bit on the very tip of the blade, but that's a really consistent, even grind down the entire blade. This is wrought iron clad 80 CRV2, I believe, and it's a pretty thin forging to begin with, a very good taper. So it's kind of challenging to grind it and get a really even grind line. But that was because this was actually used on a couple iterations of this device, of this jig. So this one might turn out fine. I might cut it short. It actually might look better at about that length rather than that. So I might cut it short. I'll just do that. But yeah, that's the jig. And this will make grinding suck a whole lot less for me, and I'm looking forward to using it on some batches for when I get prepped for the state fair. Well, I hope you enjoyed the video. Thank you for watching, and I look forward to making more content using this grinding jig and turning out some high quality blades. So thanks for watching. Bye.